Titration. Titration is a process which a standard reagent is added to a solution of analyte until the reaction between the two is judged complete. This technique is commonly used in the food industry for various purposes, primarily in the quality control and to determine the concentration of specific components in food products. Objective of titration is to determine the concentration of an unknown solution from known solution. So here, we have two apparatus that we need to have when we want to do a titration. First is burette and second thing is conical flask. Function of burette is to hold standard solution and the concentration of solution is in burette is known. Meanwhile, the function of conical flask is to hold product solution and the concentration of the solution in conical flask is unknown.
Terms in titration. Firstly, we must have a titrant. Titrant is the reactant that will react with standard solution from burette of a known concentration. Secondly, an analyte. Analyte is a sample which concentration to be determined during the experiment, during the titration. Next, equivalent point. The equivalent point is the point which an equivalent or stoichiometric amount of titrant is added to the analyte based on the stoichiometric equation. Fourth, indicator. An indicator is an organic dye that determines the endpoint showed by the color changing during the titration. And lastly, endpoint. Endpoint is the point at which the reaction is observed to be completed. Explanation on the theory of titration on food industry. Firstly, titration are widely used to regulate the amount of acid, base, and salt in the food item. Example of food product that determined by the titration is acetic acid in vinegar, mayonnaise, ketchup, lactic acid in pickle, malic acid in apple juice. Acid and base are two reactants that are taking part in the acid-base titration. This titration involves the neutralization of an acid and a base. Each use acid-base indicators that you guys can refer to the table. Theory. Conduct the titration process triplets. Calculate average volume of titrate and by using the formula M1V1 equal to M2V2.
Let's take a look for methodology. Using fruit juice as an example, citric acid is a common acid found in citrus fruit, and its concentration in fruit juice is often of interest in the food industry. For the purpose and chemical apparatus, purpose to determine the citric acid content in a fruit juice sample. For the chemical and apparatus, burette, pipette, retort stand, conical flask, funnel and white tile. For the chemical, phenolphthalein indicator, 0.1 m sodium hydroxide, distilled water and fruit juice. For standardization of sodium hydroxide, titrate the sodium hydroxide solution 0.1 m with a known quantity of azelaic acid or potassium hydrogen phthaleate. Sample of preparation. Dilute the fruit juice sample to the proper concentration and combine thoroughly.
Now, I want to briefly explain to all of you basic titration procedure. First, pipette a volume 10 ml of the dilute fruit juice into a conical flask, and then add a few drops of the selected indicators such as phenolphthalein to the diluted fruit juice, and then fill the burette with sodium hydroxide, or we call it NaOH solutions. And fourth step, we should pipette 10 ml of the diluted fruit juice into a 250 ml conical flask and then add 2 or 3 drops of phenolphthalein as an indicator. You know the phenolphthalein is like pink, right? And then the sample in the conical flask was titrated with NaOH from the burette slowly while shaking the flask until the indicator color changes. The color change for phenolphthaleins. The solution changed color from colorless to a faint pink or light pink, and the reading at the end point of the titration were recorded. Next, I record the volume of sodium hydroxide solution used to titrate the diluted fruit juice sample at the end point. And then, the last step is you just repeat 2 or 3 times and record the reading in a table. That's it.
Example of result. Table 1.0 Titration of diluted fruit juice with sodium hydroxide solution. From the table 1, we can see that the result from these trials is very close. For the trial 1, the volume of sodium hydroxide used is 21.5 ml. For the trial 2, we got 20.8 ml, and for the third one we got 22.0 ml. And we can get the average volume of sodium hydroxide used by using this formula. So at the end, the average volume of sodium hydroxide used is 21.4. So, in conclusion, we know that the measuring unknown concentration is widely used in food industry. Other than that, we also be able to determine the quantity of reactant in the sample. Lastly, it can help us understand the fundamental properties of food components that underlie food quality. That's all from us. Thank you. Bye-bye.